Vitamin E has drawn significant scientific attention for its potential role in cancer prevention, largely because of its antioxidant capabilities and ability to protect cells from oxidative stress and DNA damage. In the body, oxidative stress is caused by the buildup of free radicals, unstable molecules that can harm cellular structures, including the DNA within cells. Over time, this damage can lead to mutations that may initiate the development of cancer. Vitamin E, as a fat-soluble antioxidant, helps neutralize these free radicals, thus playing a protective role in maintaining the integrity of cell membranes and genetic material. This underlying mechanism provides the biological rationale for exploring vitamin E as a factor in cancer prevention. The most compelling hypothesis in support of vitamin E's role in reducing cancer risk focuses on its capacity to interrupt early cancer-causing processes. By preventing oxidative DNA mutations, vitamin E may limit the first steps that transform a normal cell into a potentially malignant one. It also helps preserve the function of immune cells that are responsible for identifying and eliminating abnormal or precancerous cells, which enhances the body's natural defenses. These functions make vitamin E an appealing candidate in the context of long-term cancer prevention strategies, particularly those that emphasize reducing the cellular stress and inflammation known to contribute to cancer risk. Certain observational studies have found associations between higher vitamin E intake from food and a lower risk of specific types of cancer, such as prostate, lung, and breast cancer. These findings are especially promising when vitamin E is consumed as part of a varied diet rich in whole foods like nuts, seeds, spinach, and plant oils, which contain a mix of natural antioxidants and phytonutrients that work together to protect the body. In such a dietary context, vitamin E does not act alone, but rather as part of a broad team of nutrients that help reduce inflammation, support immune surveillance, and promote healthy cell turnover. However, the research landscape becomes more complex when vitamin E supplementation is examined in isolation. Large-scale clinical trials using high-dose vitamin E supplements have not consistently shown a benefit in cancer prevention and, in some cases, have raised concerns. For example, some studies found that very high doses of synthetic vitamin E supplements may increase the risk of prostate cancer or interfere with the balance of other antioxidants in the body. This does not suggest that vitamin E itself is harmful, but rather that the context, form, and dose in which it is consumed matter greatly. Nutrients that are helpful in moderate, food-based amounts may not yield the same effects when isolated and consumed in pharmacological doses. This distinction reinforces a broader principle in nutrition science. Whole food sources of vitamins tend to be safer and more effective for long-term health than high-dose supplements. In the case of vitamin E, consuming it through natural sources like almonds, sunflower seeds, hazelnuts, avocado, and leafy greens allows the body to absorb and utilize it alongside other synergistic compounds. These foods not only supply vitamin E in its natural tocopherol and tocotrienol forms, but also provide additional antioxidants like selenium, vitamin C, and flavonoids, which can amplify its protective effects against DNA damage and cellular aging. While the current evidence does not support the use of high-dose vitamin E supplements for cancer prevention, it does highlight the value of maintaining adequate vitamin E intake as part of a comprehensive, health-supportive diet. Individuals with low antioxidant status or poor dietary habits may particularly benefit from ensuring they consume enough vitamin E-rich foods. Likewise, those at higher risk of oxidative stress, such as smokers, individuals with chronic inflammation, or those exposed to environmental toxins, may find that supporting their antioxidant defenses through food-based vitamin E helps lower their overall cancer risk profile. In summary, vitamin E plays a quietly powerful role in cellular protection that may contribute to cancer prevention over time. Its ability to guard against oxidative DNA damage, support immune defense, and reduce chronic inflammation makes it an important nutrient in the broader context of cancer risk reduction. While it is not a cure or a standalone solution, vitamin E, when consumed as part of a nutrient-rich diet, adds a valuable layer of defense that supports the body's ongoing efforts to maintain cellular health and resist disease. The most effective approach is not found in high-dose pills, but in the steady, balanced nourishment of whole foods that work in harmony with the body's natural systems.